If you are evaluating authorization for 2026, you are likely balancing three pressures. First, you need strong, auditable security controls that scale across microservices and user populations. Second, developers want to avoid reinventing authorization for every endpoint and view. Third, business and compliance teams need self-service guardrails that do not require weekly engineering tickets. Permit.io aims to solve this by pairing a powerful policy engine with a no-code interface and modern operational tooling. At the heart of Permit.io is Open Policy Agent, or OPA, a battle-tested engine for policy evaluation. OPA enables you to define fine-grained rules that answer a simple question: should this subject be allowed to perform this action on this resource, given the current context? Permit.io adds a practical, user-friendly layer over OPA, so you don't have to write or maintain all of the policy logic by hand, and it integrates OPAL to distribute policy and data changes in near real-time across your infrastructure. A common way to think about the platform is through the PEP, TDP, and PIP model. Your services and UIs are the policy enforcement points, which call out to a policy decision point, often an OPA instance managed and updated by Permit.io. The decision point evaluates policies and attributes that come from policy information points, such as your identity provider, HR database, CRM, data warehouse, or application state. This decouples authorization from business logic, makes decisions consistent, and provides a unified place to audit and evolve rules. Permit.io supports core authorization models that teams use most often. You can define role-based access control to grant actions based on assigned roles like admin, manager, or viewer. You can layer attribute-based access control to enforce conditions like department equals finance, region equals EU, project equals X, time of day within a window, or risk score below a threshold. Some teams also model relationship-style rules using resource hierarchies or ownership, for example, allowing a user to edit only the records they created or those in a team they manage. The visual editor and schema tools are designed so that security and operations stakeholders can understand and propose changes without diving into code. A core value of the platform is operational maturity. Policies are versioned, so you can review changes, run tests, and promote updates through dev, staging, and production with approval workflows. You can create tenants to separate customers or business units and apply least privilege defaults. Decision logs capture who requested access, what decision was made, which policy version applied, and what attributes were evaluated. These logs support incident investigations, audit readiness, and fine-tuning of policies over time. On the developer experience side, Permit.io provides APIs and SDKs to integrate authorization checks in backend services and frontends. Engineers often embed a simple check allow, deny, or explain into endpoint handlers, middleware, or UI components. Decision caching reduces round trips for hot paths, while background refresh keeps policies and attributes up to date. Because policy is externalized, the same authorization decision can govern a REST API, a GraphQL resolver, a gRPC method, and a page-level UI element, eliminating duplicated logic and fragile conditionals. A frequent question is whether Permit.io uses AI. The critical point is that enforcement remains deterministic and explainable through policy as code. That is a strength for security, compliance, and predictability. AI can still assist around the edges, for example by suggesting policy templates, helping administrators search documentation and rules, or surfacing analytics that reveal unused permissions and opportunities to adopt least privilege. But the allow or deny decision path is grounded in rules you can review, test, and audit. Performance and scaling are essential considerations. In practice, teams combine local decision caching, efficient attribute retrieval, and OPAL-driven updates to reach low-latency checks even under heavy load. For multi-tenant SaaS, you can partition policies and data per tenant to avoid cross-tenant leakage and simplify incident response. If you operate in regulated environments or have strict data residency needs, discuss deployment options such as running enforcement close to your services and controlling where logs and attributes are stored. Governance features aim to reduce friction between security and product teams. Self-service access requests let users ask for a permission with a documented justification. Approvals can route to managers or resource owners. Time-bound grants and just-in-time access reduce standing privileges. Audit trails record each grant and revoke, which helps with regulatory frameworks and internal controls. These features usually replace ad hoc spreadsheets, untracked admin changes, and one-off database updates that become liabilities during audits. Pricing typically scales by usage, feature tier, and support level. The return on investment comes from standardizing authorization logic once and reusing it everywhere, shortening delivery cycles and preventing privilege gaps that can lead to incidents. To estimate benefits, compare the engineering hours required to build and maintain custom authorization across microservices, admin consoles, and reporting tools versus a managed, testable policy layer that both developers and non-technical stakeholders can operate. Implementation best practices start with a clear domain model. Inventory your resources and actions. Identify roles that are stable and attributes that vary frequently, such as departments, regions, or project memberships. Start with a minimal set of permissions that enable core workflows, add conditional rules for sensitive actions, and layer approvals for high-risk changes. Define ownership for policy reviews, promotion between environments, and incident response. Measure success by tracking lead time for permission changes, audit completeness, and reductions in authorization-related defects. If you are comparing alternatives, consider Acerto, Cerbos, Oso, AuthZeed with SpiceDB, Okta fine-grained authorization, and AWS verified permissions. Evaluate 4 areas closely. First, model flexibility and usability for both developers and non-technical users. Second, operational tooling, such as versioning, testing, rollout, and audit. Third, performance characteristics and caching strategies across your architecture. Fourth, ecosystem fit, including identity providers, data sources, programming languages, deployment options, and multi-tenant separation. There are also pitfalls to avoid. Do not attempt to migrate every edge case on day one. Start with core routes and expand iteratively. Avoid embedding resource identifiers and conditions directly in code where they are difficult to change. Centralize decisions in the policy layer and pass only the attributes needed for evaluation. Build tests for common scenarios such as new user onboarding, role changes, and tenant separation. Finally, document a deprovisioning flow to remove access quickly when users leave or change roles. In summary, Permit.io takes the power of OPA and makes it approachable for cross-functional teams. It brings a no-code and low-code surface to policy as code, aligns with modern PEP and PDP patterns, and supplies the governance and audit features enterprises require. Its emphasis on determinism over opaque AI decisioning provides clarity and trust in high-stakes environments. If your roadmap includes fine-grained, explainable authorization that scales with your product and organization, Permit.io is a strong contender to put at the top of your evaluation list.